Imagine you're an engineer creating blueprints for an amusement park, and you were asked to design a Ferris wheel and a cable car at different elevations. How would you do so? Now that is a question involving inequality, the subject I will be explaining today. In order to place the cable car above the Ferris wheel, first we need to make sure that the two don't collide. So first, we need to find the height of the Ferris wheel and all the possible heights it could go. So assuming that the height of the Ferris wheel is 10 meters tall and that it is 2 meters above ground. Together, this is 12 meters. Now let's let h be all the possible values for the height that the Ferris wheel can travel, which is this 10-meter portions over here. And if we were to write that in inequality, it would be h is larger and equals to 2, and smaller were equal to 12, because 10 plus 2, which is 12. Now, of course, this is in meters, the measurement. Now, if we were to build a cable car, we would obviously want it to be either lower than 2 meters in height or higher than 12 meters in height. Obviously, we would pick the 12 meters because that's the more logical explanation. So you know that if you were to build a cable car, of course, putting in consideration the size of the cable car, that you would put it at least above 12 meters, somewhere up here. Here we see a coordinate plane, and this is one of the tools that can really help us understand inequalities. The other one being a number line, which I will show later. As you may have noticed, I plotted some points in the coordinate plane, such as these. As you can see there, I have just labeled my graph, and this is the graph for all the heights of the Ferris wheel cart, starting at the minimum height 2, all the way up to the maximum height 12, in correlation to the time in minutes. And an actual graph would look something like this. As you can observe, the height never goes above 12, this line, nor below 2, this line, representing the inequality we wrote earlier, which was h is smaller or equal to 12 and larger and equal to 2. Now, here we have a number line, as you can see at the bottom. And we're also going to learn how to represent inequalities on a number line. As an example, we'll begin with the current inequality we have now. We'll start with 12. Let's start with finding 12 on the number line, which is right here, and I'm just going to use yellow to show difference. You're going to want to draw a filled dot, and next we're going to find our next number, which is 2. H is larger or and equal to 2. So we're going to find 2, and we're going to put a dot there too as well. There are two types of dot that can be put there. The first one is the filled dot, as we have just seen, and the second one is a dot that's not filled. A filled dot means that the current digit is included within the range of numbers that can in the inequality. So in this case, 2 is actually included because h can equal to 2, so it's a filled dot. And the symbols for a filled dot would be either this or this. Larger than and equal to, or smaller than and equal to. For a non-filled dot, the digit at hand would not actually apply, the integer at hand. And the symbols would be just smaller than or larger than. For our current example, both of them actually include the digit that I have circled in red. So these two are both filled dots. And next, what we would want to do is just put a line connecting the two. And that's just how you represent h is smaller and equal to 12 and larger and equal to 2 on the number line. As you can see, the range that is represented by this line perfectly includes any number that is possible for this inequality. We're now going to practice inequalities on the number line with one more example. X is larger than 3. Okay, now we have our number lines, we can start plotting. This inequality is a bit different from the other ones as, first of all, it doesn't have exact range, and it's not larger and equal to, nor smaller and equal to. So let's see how we're going to plot this one. First, we want to plot a point at the number 3. And in this case, we are going to plot a point that is not filled because this is not larger and equal to. So we're going to just draw that there. And now you would realize that there is no other inequality stopping the h from extending, meaning that h would go on for infinity if you let it. In this situation, what you want to do is draw a line and simply put an arrow. That indicates that it will go all the way to infinity. So that is how you draw an inequality that goes on to infinity and one that does not include the digit that is at. So 3 is not a possible solution to h, and we're going to bring this up later. One question that often gets asked is whether an equation is actually equal to an inequality. Are they the exact same thing? Well, unfortunately, no. Although both equations and inequalities make use of variables, they are different for one reason. For equations, the two sides are equal, while for inequalities, the two sides are not equal. Another difference between the two, while equations are mainly used to solve problems, inequalities are usually used to represent the range of something, as we have shown in the example with the Ferris wheel, with the range of heights that it can actually go with. In mathematics, inequalities are often used to represent the possible x and y values in an equation. Alright, now we have a new inequality here. N is larger than 6. And if I were to tell you to give me an example of what n could be, most likely you would give a numbers something like 7, 100, or whatever. However, there is also an answer that people often give, however, is actually a mistake, which is number 6. That is not an answer to n is larger than 6, because since n is larger than 6, it cannot be 6 itself. And I have previously mentioned this 2 slides back, right here, where this doesn't actually include 3. Thus, 6 is not an answer to the inequality. Any number larger than 6 will be a correct answer to the inequality. Alright, next we're going to look at an inequality that has no solution at all. X squared is smaller than 0. Try any number you like. There will not be a single one that satisfies this inequality. The reason behind this is because any number squared will always be larger or equal to 0. Even negative numbers. For example, negative 1 squared equals to 1 because negative 1 times negative 1 is 1. And that is, of course, larger than 0. 1 is larger than 0. Any positive number, for instance, let's take 7. 7 squared would simply be 49. And even 0 itself will only equals to 0. However, as we have just seen on the previous slide, this means that x cannot be 0, which means that this inequality actually has no solution at all. And feel free to try to find any solutions. They will not work, because any number squared will always be larger or equals to 0, which is shown by this inequality. Now we're going to take a look at something a little bit different. The inequality negative 5n is smaller or equals to 25. We've learned how to graph inequalities, however, we do not know how to graph these, because what we learned are only inequalities where the variable is simply given the range. For instance, this one. Now, how would you solve one where the range of the variable has not yet been completely finished, like this one? Well, you would do pretty much the exact same thing as you would do an equation. You balance both sides out and leaving the variable in singular form on one side and the number or the value on the other. It's the exact same thing for inequalities. And we are going to take a look at this example. So if we multiply -1 on both sides to get rid of the negative, we end up with 5n is larger or equals to -25. Now, you may be wondering why this sign changed. Well, that is because you multiplied a negative over, in which case you will have to switch the sign in the middle to the opposite of it. Larger than changes into smaller than changes into larger than, larger or equal to changes into smaller or equal to, and so on. Now, next, we can continue solving our inequality. So next, we can divide 5 on both sides. So we get n is larger or equals to -5. And that is our answer. Now we're going to graph this, both a number line and a coordinate plane. Alright, first we're going to graph the answer n is larger or equals to -5 on the coordinate plane. We're going to assume that the x-axis is actually the n-axis to make it easier because of our variable. And we're still going to assume that the y-axis is the same thing as the y-axis. There is one problem with graphing this. What this will end up being is essentially an infinite square. So we're going to give a y value just to let you have an idea of what this would be. We're going to assume that y equals to -2, because why not? So first, we must find -5 on our coordinate plane. And in this case, -5 is right here. And we are going to assume that y equals to -2, so we're going to move that to -2, which is right here, -5, -2. You know how to plot points on the coordinate plane. And what this will eventually be will be an infinite line right here. First, let me show you what this whole thing would look like if we did not define an y value like we did here. Usually, when graphing an inequality on a coordinate plane, you would want for there to be both an x and y value. In our case, both an n and y value. So I'm going to just represent in blue, shaded in which region it would be if we did not set the y limit. And it's going to be pretty massive. Yep. Essentially, anything beyond this line right here is considered to be greater or equals to -5. However, we're not going to graph it this way. With y equals to -2, the line would be right here. And also remember that here is a filled dot because -5 is included as a value of n. And that would be how you graph n is larger or equals to -5. Or if we go back to the original question, -5n is smaller or equals to 25. Alright, next we are going to graph n is larger or equals to -5 on the number line. First, we find -5 on the number line, which is right here, and we are going to draw a fill dot over it. Because one possible n value is actually -5 due to the sign here. So we're going to do a fill dot and extend the line over point arrow, indicating that n can be any value larger or equals to -5. Alright, next we're going to try another example. 2j minus 10 is smaller than -4. So we're going to do the exact same thing as we would an equation. So first, you plus 10 on both sides, which makes this 2j is smaller than 6. And next, you divide 2 on both sides, making this j is smaller than 3. And that is our answer for this question. Now we're going to graph this on the number line. Remember that the answer is j is smaller than 3. As I've written right here, we're not going to do this on the coordinate plane because there's really no point. And the coordinate plane is really for when there are two variables which has ranges. Alright, now in order to graph j is smaller than 3, we need to first find 3 on the number line, which is right here. We're going to plot a hollow point over it and extend it by an arrow towards -infinity because j is anything smaller than 3. Remember that this dot is left hollow because j cannot actually be 3 itself. Now it's time for a word problem. Mari has x number of pencils. All the possible number of pencils can be represented with the inequality -2x minus 7 is larger than x minus 28. Paul needs to borrow 7 pencils. Is it possible that Mary has enough pencils for Paul to borrow? If you want, feel free to solve this on your own. I'll wait for a few seconds, and then I'll begin solving the problem. Alright, now, so first we are going to copy down the inequality, so it's clear. Okay, first what we're going to do is we're going to plus 7 on both sides. So what ends up happening is -2x is larger than x minus 21. Alright, so now we see that we have our number right here, so we want to move this x over there. So we are going to minus x on both sides, which gives us -3x is larger than -21. Okay, I'm going to move on to the next slide. So just copy it down. This is what we have so far. -3x is larger than -21. Now we multiply -1 on both sides, and we get 3x is smaller than 21. Then we can divide 3 on both sides and get x is smaller than 7. Now let's look back at the original question. Paul needs to borrow 7 pencils. So does Mary have enough pencils for Paul to borrow? Well, x is smaller than 7, meaning that x cannot be 7. This means that the answer to this question is no. Mary does not have enough pencils for Paul to borrow. That's all. Thank you very much for watching today. Goodbye. Have a great day.